Motion review. W1 quiz position review. So an object moves from A to B to C to D along a rectangular distance, or the rectangular shown. Find the distance covered. Okay, so let's do that. So A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's 13 kilometers. So the distance is the track. You follow the path. It can be curvy path, just have a start and a finish, or in this particular case, it's really easy to calculate because we're just counting up the blocks, 1 kilometer blocks. So motion is a process of an object changing position from one location to another. So distance versus displacement. So distance is this from the start to finish, it's the total path. Now, displacement is this linear distance that goes from the start to the finish. So displacement, and it also has a direction. So displacement has a direction. So this particular case, if we had north, south, east, this would be kind of from the finish. The distance, the displacement is southeast, and however long this is. So that's the difference between distance and displacement. So we sometimes need to find displacement, but not all. Most of the time, we just find the distance. But we do think of it as something that has a direction to it. Distance does not. So linear distance definition is the shortest line between the start and finish. So the shortest line in this particular case is this. And then we have the path here. So it was south. This is backwards. Southeast. Realize that. So the difference between distance and displacement. Distance is how far an object's total moves in total, and displacement, the distance and direction an object moves from the starting point. So sometimes we call that a linear. Right? So we'll take a look at those examples here. So here is the displacement. So this is my start, and here's my finish. So notice that the distance and displacement are the same. This one might have a direction in it, maybe forward instead of backward. So these are from the home plate to first base is 90 feet. Now, if I follow the distance and I go to second base, it's going to add another 90 feet. So my distance now is going to be 180 feet. But if I do the linear displacement, it's only 127 feet here. So my displacement's 127. If I go all the way around, 90, 90, 90, I make a home run. Now my distance is 360. But remember, we're talking about from the start to finish. If they become the same, my displacement is 0. Okay, so the displacement can be the same as the distance. Distance versus displacement can be the same as the distance in this particular case, and it could be smaller. than the total because we got 0 if we go all the way around. So distance and displacement. Distance is talked about as a scalar. It only has a number, where it's a measurement only and no direction. But a vector can be positive or negative. See, this is always positive. And the magnitude has a direction with it. All right, so and the SI units, or the science uses meters. We can both use those in meters, but we have a direction going along with it. Other things that are vectors: velocity, acceleration, displacement. Speed is a scalar, just a number with a unit. So 60 miles per hour looks like that's something like a direction, but it's not. That's just a unit. So let's take a look at here. A lot of times you have to make a drawing. Eddie starts. So we're going to look for the displacement. So we need to have a direction. That's why we have the direction here. Eddie starts 2 meters east of his house. So right here, east. He moves 1 meter south, 5 meters west, 1, 2, 3, 4, 5, and then 1 meter north. So right there. So Eddie is 2 meters and west of the original location. So the start was the house, 2 meters west. So when you do these kinds of things, you have to draw them out. It's always a good idea to draw them out in order to answer the question. Now let's take a look at some vectors. Vectors have magnitude, and sometimes they have numbers. You can add numbers to this, but you can see that the red one is shorter. So if this was me pushing a cart or a block of wood or something like this, I would be pushing with less force than the blue. All right. So these vectors, so which one has the greatest magnitude? It's the blue one. We add up vectors, so like here's what we would think about. If we have a red vector and a blue vector, 2 people pushing on the block, and let's say we're pushing and it's on rough ground, certainly both together, even if somebody's pushing harder, is going to make it easier to push. So we can add those 2 together, and we use what they call the tip to tail. So a vector is drawn on top of the other vector. So these were from the last one. So let's say we're going to add those together. Here's the tail and the tip together. And so this would be the amount of force, so to speak. So if this was 9 and this was 3, I get 12. The magnitude is 12 to the right. So adding, they line up tip to tail. The sum of the vectors drawn from the tail to the first. Right, so in vector addition, some can be put numbers of magnitude 2. We can make this a 5 and this a 3. And add or subtract based on the direction. So here we have a 5 and a 3, and this one's going left and this one's going right. So if I put this one on top of here, you'll notice that there's some left over. So if I have some left over, it is whatever direction the one underneath was. So it was going this direction. So 2 to the right. So we subtracted 5. So that would be kind of like an idea here would be like if I was pushing with 5 units. And let's say I had underneath here rough ground. That would be considered friction. So it's opposing my moving. So I've got 3 units of friction. Certainly, if you were to slide it on ice, you'd have hardly any friction at all. So we take that into account. That's where vectors go, force vectors. So this was 5, but 3 is pushing back on me or holding me back. So I only get 2 total in this direction. So that subtracts them. So I only get 2 to the right. Just an application. We'll be talking about that later. So let's do vectors, draw a vector of 15 magnitude. So let's do that. I'm going to draw a vector 15. I started with 0, and I can do that. So 15. And then that's to the right. And the magnitude of 9 going to the left. Let's put this one in red. 9 going to the left. So I'm going to put this 5, 9. Didn't do a very good drawing of my 9, but here we go. Got 9 going to the left. So I still have 6 going to the right. So 6 right. Right, vector addition can be quite complicated. So here we go. We went tip to tail, tip to tail, tip to tail. And then what we do is we draw a line that goes from the bottom of the first one and the top of the other one. And it takes a little bit of trigonometry to do these. Okay, that is what I have for you on the, I'm going to pause it a second. Okay, the last part of this review is just the vocabulary. Scalar, examples of scalar are just numbers with the units, no vector. It has no west or east. Magnitude is only numbers, and it's the size. So distance, speed, length, temperature, mass, all those are scalars. Distance, we talked about that again. That's the total distance around, total pathway. The linear distance is the displacement from the start to the finish, shortest path. It's not the total length. Magnitude is the quantity of how big it is. So the magnitude of a vector can be its length. Sometimes we can put numbers on them. An example would be an earthquake. And it's a scalar, not meant to be a vector. All right, so velocity is an example of a vector because you have distance, the shortest distance, shortest path uses the velocity is displacement divided by time. So not this total distance here, but just the shortest distance. That's velocity. Position, the location in a frame of reference. Okay, so Could be the treasure chest, could be somewhere here. So we usually have a coordinate system. So like this is a coordinate system. So it has a grid, numbers and letters, or number X and Y coordinates, right? And they are set up so you can find your way. So position is where you're located on a map. Motion, the process of changing position, right? So we need things like frame of references. And of course, this is a blurry picture, but because we have something this is going past, you can tell you're moving. If you didn't have a frame of reference point or a reference point like a tree or fixed object, it would be very hard to tell if you moved or not. Okay, speed is the rate of change, how fast something goes in the total distance, not the displacement. That's velocity, and that's a vector. Is a vector because we have north, south, and east and west. So my final destination was here, was south of A. But here we don't worry about, this is a scalar quantity. We don't worry about the direction. Just measure the path and how much time it takes. So distance divided by time gives us the speed. We've done displacement. Displacement is the linear distance and direction between 2 points. A vector is a quantity that are described by both its size or magnitude and the direction. So, and again, this is backwards. 15 miles an hour, miles to the west, backward 4 feet. And a vector quantity, if we look at 9 meters per second squared, that's acceleration, and that is a vector. So something to remember as far as a number. All right.